8:30 for the test. It will be closed book, closed notes. You will need pencil and a calculator. The deep sigh that just came out after a calculator, is that
Yeah.
If you're totally prepared for this test, I think it's probably about 20-minute test. I'll allow an hour. It's going to be broken into many different areas. For the most part, it is sketching and true false.
Your favorite kind of true false?
Yep. The only kind of true false we do. There will be some very minor calculations. You will not need to have beam charts or anything like that. Anything that you do need, I will provide you with. But I'm thinking that the calculations I've got on there is stuff that we cover. Okay, so you shouldn't need any supporting stuff for it. That's kind of the generic. Okay. Once you're done with that in your drawing, you're done and you're pretty much done with the program. Those of you that are still hanging around or whatever, Dave, I know I've got something to do with you yet, and we'll get that to you before the week's out. I hope to have everything graded by Thursday. If you wish to scoop up your stuff, at the end of day Thursday, I should have everything graded. That'll give me Friday in case any of you have an outstanding drawing still out or whatever to get those done and finished in the grade book by my deadline, which is Friday afternoon. You might want to bring a flash drive in and take what's on your hard drives. We won't do anything with these computers until I come back, I think August 12th or so, and then we will just wipe them clean. Okay, these computers are actually going somewhere else and they're bringing some new ones in. But if you want your stuff, which I'd recommend you get a flash drive, copy all your stuff over. Okay, and take it with you. Anything left in the flat files, when I come back on August 12th, will also be thrown. Okay, so if you want any of that stuff for a portfolio or whatever, or maybe you're trying to put one together and you need to use the plotter to get that, and please do. If you're hanging around the area and you're unemployed at this point, stay in contact with me. We do have another hire cycle that generally happens around September. Now that hire cycle, the one you saw in May is when everybody comes out of winter and they're gearing up for construction. They know their staffing forces. They also we have a hire cycle in September where firms are going into the winter saying, oh, I've got all this work to get done by next year. I need this people. And so we have another hiring cycle where things really pick up. And so stay in contact with me if you would. And I can feed you any of that comes our way.
Just through your email? Is that who?
Email's probably the best way.
Okay.
Yeah, certainly my cell phone, I really am very bad about checking it. But I do check my email fairly regularly. All right, shall we talk about the different materials? Just do a brief overview. We've got about 20 minutes here where we can go through these. Let me just kind of re-hit through our notes. We only had approximately 5 lectures that I'm really going to test over. I'm going to leave your drawing for a large part of this. Keep in mind structural drafting. Drafting the bones of a building or a structure. That's what structural is. If we really don't care about anything else, we're just looking at the physical forces that a structure goes under and designing for those. Typically, this work is done by a civil or structural engineer. The drafters support that activity, communicate the concept of the design. We talked about these 5 forces here, which we should be familiar with. Certainly the top 2 are tension and compression. Tension, you're pulling something apart. Compression, you're pushing something together. Now with that said, we still have some other forces out there that you will see when you get into this, or at least have discussions on. You have shear, which happens on beams, and it is a cutting action when we have two forces too close to each other. And it'll be just like a pair of scissors. It'll cut, shear, and the name kind of denotes that. You have torque, which is a twisting motion. And you also have a moment force, which is in essence a lever. So it's a point load that is some distance from its support. Okay, so think of a lever when you think of moment. We do free body diagrams, kind of like these, and so FBDs are free body diagrams, and in essence, here's a few of them, where this is where we are isolating the structural item in question and analyzing all of the forces working on it. And we kind of went over real basic. If we do a continuous load, we show it like such. So it's continuous. If we have a point load, we get one vector on it, it's usually labeled force of something. We always have to have reactionary forces that are equal to or greater, and almost always greater, than the forces being applied. Remember this factor of safety. This little equation here. Certainly for the residential commercial market, we're anywhere from 1.3 to 1.5. But the factor of safety is equal to the structural member strength divided by the required strength of the situation. So as an example, if I had a beam that was capable of carrying 175 pounds per square foot or per linear foot, so that's what the beam's capable of, I'm going to load it with 100 pounds per linear foot. What would my factor of safety be?
Say it again.
My beam is capable of carrying 175 pounds per linear foot. I'm going to load it with 100 pounds per linear foot.
1.75.
Okay? Be 1.75, right? How'd you get that number, Cheryl?
Plugged it in and divided.
Structural member strength, 175 pounds per linear foot. What am I going to load it with? 100 pounds per linear foot. Divide the two together, and it gives you an idea. Anything down below a 1.2 or so, you're probably beefing this guy up to make it a little stronger. So that was kind of, let's see, some of the basics of structural. When we don't know the exact conditions, we use two terms, dead load and live load. Okay. What are those two?
Live-
John?
oh, sorry. Go ahead. No, I didn't know you raised your hand, I'm sorry.
Dead load is just kind of like a constant weight that that doesn't move, and live load would be like people that is moving around. It's not a constant weight on that area.
Yeah, that's putting it pretty well. Yeah. That'll know it. Dead load, weight of the structure itself. Live load, all the movable forces, all the variable forces. I also think of it as what's nailed down and what's not. All right, from there, we went to the different terminology of the structure. We went through floor, foundations, through floors, through walls, through the roof, and the different structural items that we have in there. Remember this little talk? where we came through and we talked about the footing, the lowest part of the foundation. Generally, there's some type of stem wall in our country that gets you through the soil horizon. And then probably a base plate or sill plate at the bottom, which is a nailing surface. And generally that makes up your foundation. Footing, stem wall, sill plate. When we come to floors, before I leave foundations, its job, disperse the weight into the soil. Floors, platform for occupant use, generally made of joists with decking. The joists are the supporting members. The decking is the platform for occupant use. We can make these out of a variety of deal. We can use joists and wood. We can use just a straight platform with concrete like you designed up. A lot of different types. Walls. When we're talking about walls here for structural, generally we are talking the exterior walls. They're basically vertical. Their job is to transport weight from one floor to the next. You do have some components in there, such as beams and columns, where a beam's job is to transfer weight laterally or horizontally to a column. A column's job is to pass the weight from one floor to the next, just like a wall. We used all our materials on this. Roofs. Depending on the type of roof you have, you might have 3 or 4 different configurations. We have our standard truss roof, of which you're going to get lots of examples this morning. Those typically reside on the exterior walls. You can also do a beam, a girder, and purlin system, which is also very similar to a rafter beam and rafters, more like you would use for a cathedral ceiling. Any questions on any of those terms? Okay. From there we went into our 3 main materials. And we spent quite a bit of time on this. So we talked about steel, concrete, and wood, which are our 3 main structural materials. And certainly we use them in all those situations we just listed: floors, walls, foundations, etc. We use all of them in all those situations. The thing we want to know is just some of the basics of them. Okay. So let's just start with concrete. There is some things on concrete. Remember, you have really 3 types of concrete. So you have concrete, which is your clay, silica, lime, or excuse me, that is cement. Okay. That's just the basic powder that hardens up. Concrete is cement with aggregate added. Keep in mind when we do that, the aggregate is the strong component, the cement's the weak component. Then we have reinforced concrete, which we're adding generally steel, but it can be fiberglass or something like that also. Generally, when we do reinforced concrete, we're thinking of rebar interjected into the concrete. When we deal with concrete, a couple of the really nice things, it has a very high compressive strength, so it makes it ideal for foundations. It's not carbon-based, so we don't have to protect it. We do know that it will crack though, and we've got a couple formula that I brought out. So when we're dealing with concrete, we know that at 28 days it needs to be at 100% of the design strength. The other thing we have to know is that when we come in, and I'll just come down to this bottom part of my notes here, you have 2 formula that you pre-crack the concrete with. So one of them is right here, the compression joint. You take the thickness of the slab, times it by 2.5. The thickness is in inches, by the way. Times it by 2.5, and that's the spacing of your cuts in feet. The other one is when you get a rectangular piece, you take the short dimension, times it by 1.5, and you also have to cut on that spacing. So as a quick example, if I have a 4-inch concrete slab I'm using as a platform, I would take 4 times it by 2.5, that means 10 feet. I know I'm going to go in and pre-cut that slab every 10 feet before I put it into production. If it's like a sidewalk or a long deck or linear piece, more of a rectangle shape, I take the short side, times it by 1.5. So if let's say we're doing a walkway up to a house, we're going to make it 4 feet wide, but it's going to stretch for, I don't know, 50 feet. You take the 4, times it by 1.5, that's going to be 6. And I need to cut it every 6 feet. Any questions on those? Any questions on concrete? Okay. Then we went to wood. Actually went to steel next, but I've got wood in my notes next. So on wood, our strongest material per weight out of all 3 of these. Now that's only when the force is acting parallel to the grain. Okay, so we want our forces acting parallel to the grain. Hence the reason our structural wood, like Select Structural and number 1, 2x4, 2x6, etc., are all cut parallel to the grain. Okay. We do use a lot of engineered lumber, which is softwood species, put in either a sheet or chip formation. Typically, what these do is just utilize soft woods, bring them into the market, so we don't have the wood shortage that we normally would have this situation. They're not really any stronger than natural wood, but they are as strong. We can also put it in different shapes. Usually it's a rectangle, but like a floor joist, we can put it in the shape of like an I-beam or something like that also. High fire situations, you use wood. You do have to protect it. I'm not going to talk about any of the nails or anything that we use with it. Any questions on wood?
What is the fire situation? I mean, we talked about steel and wood, but you didn't really mention concrete. Is it even worse than steel?
No, concrete's great in fires. Okay, because it's a thermal retainer, a heat. So concrete, you can't burn, right? Now, what you can do is you can heat it enough to melt the rebar in it, if it's reinforced concrete. But that takes a long, long time, because concrete's like a rock, right? It will not change temperature quickly. But certainly, we can generate temperatures that will melt rock. So you can do that. But yeah, it's actually the best. But the problem is it's so heavy, we don't have a lot of it up, right, in the upper portions. Not at least where people are. Certainly we got big concrete beams up in the air, but they're on roadways and stuff like that, right? They're not really in a structure like this, where people can get hurt. So no, if you could do concrete, that's the best of them all.
So steel is the worst for fire.
Yeah, and I wouldn't say it's the worst. I don't know that it goes any faster than wood. The thing is, you can't visually tell when it's going to fail. Okay, so a firefighter runs into a building, it's on fire. They look at a wood beam, you can see, oh, it's burned a quarter of the way through, or it's starting to sag and I can see a crack in it. You can see all that stuff visually. They can make a snap decision on the point. Right then, do I keep going or don't I? With steel, there is no visible outside at all, okay? Especially if it's painted red. Now, because metal will turn red when it gets hot, right? And it'll look like it's almost on fire, like molten lava, but by the time it gets to that look, it's already failed. And you just can't tell when it's going to go. It's strictly a visual thing. Anything else on those? Okay, steel. Steel's made of iron and carbon. More carbon, stronger the steel. We use it in all items. It is our strongest material per volume. Strongest material per volume. Be familiar with your steel shapes. Concrete has some shapes also, but we didn't really get into them that much. I am going to get into them to test the steel shapes. So let me just real quickly turn to those couple pages here. It's in chapter 42. Okay, so the concrete stuff was on 1068. I'm not going to test you a lot on this, but remember we did have our concrete shape for bridges, platforms that were shown here, as well as CMUs, which are really our exterior walls. Remember what a CMU is? Okay. So that's in essence those. What I really believe I will get into, because these don't change and haven't changed for a long time, is on page 1076, where we talked about your steel shapes and how we make up clips and stuff like that for it. So figure 42, 45, I would know these. I'm going to ask you about these. Please maybe make a note. There's one shape on here that's used quite a bit that's not on here. Does anybody remember that one?
Angle? Oh no, angle's up there.
What's that? There's actually two shapes we use quite often.
The sheet?
A sheet? Yeah, plate steel is one. We use a lot of plate steel in the structural world, mostly in manufacturing clips and hangers and these types of things. So that's one. Make sure you remember that, and that we do get a lot of just big pieces that we cut up. And that's plate. We have another solid piece that's not on here.
Bar.
Thank you. Circular, but it's no hole in it, right? Bar is a solid cylinder. All right, I think that's probably, you got that stuff down? You're in pretty good shape. Are there any other questions? Okay, if you need to use the restroom, now would be a time to use it. How are we going to travel out there? Like I said, I think I can take everybody if we all crowded in, but if you want to take 2 rigs, we can, or 3.
Got lots of room in my truck too.
Okay, Sean, you want to drive one then, and just pile into my rig and Sean's rig, and we'll head out there. So if you need to use the restroom, let's say we're leaving the parking lot at 20 till. That should put us there right at 9 o'clock. We'll come back here after. I'm envisioning Jonathan, who's going to give the tour, said they're swamped. So I told him to go fast because we don't want to impact him too much. So hour and a half we'll be on site and then head back there.